There's two types of charges. There's the electrons and protons that we discussed already, and we talked about the three ways to give an object a charge, whether it be through friction, contact, or induction. So now that these objects have charges, what do they do to one another? Well, they're going to exert pushes and pulls on one another, which are forces. So we refer to these as electric forces. Now, if you have two oppositely charged objects, one object that is positive, one object that is negative, they're going to attract each other. So you might have heard the old adage that opposites attract. Hopefully that will help you remember in the electricity that opposites also attract. If we have two charges that are the same, so one object that's positively charged, and another object that's positively charged, then they are going to repel each other. Likewise, if we have one object that's negatively charged and another object that's negatively charged, they will also repel each other. So like charges will repel, although opposites will attract. The symbol for electric force, since it's a force, we will use the letter F, but we use a subscript electric. But I'm okay here if we just even abbreviate that further. This is what our book does, but if we abbreviate it just with an E. To be honest with you, the whole word electric is not much of an abbreviation. For any type of force, the units will always be newtons, and that's no different in our situation here. So electric force will also be measured in newtons. Now the equation for electric force is that we take this constant, which we call Coulomb's constant, the letter K, which is 8.99 times 10 to the 9th newtons times meters squared per Coulomb squared. So we're going to take that constant multiplied by each charge separately, but we must make sure that our Q, which is our charge, we must make sure that that is measured in coulombs. And we divide by the distance between the charges. So R is not a radius, R is instead the distance between the charges. And we are going to measure that distance in meters. So we've got to be careful. We want to make sure that our charge Q is in coulombs and our distance R is in meters. Now, a lot of times we'll be given, we're not talking about a whole coulomb of charge, we'll be given a prefix. Some of the prefixes we're familiar with, like centi, milli, kilo, that type of thing. But we're talking about even smaller amount of charge than that. So we want to be careful here with our prefixes. A common prefix might be a millicoulomb. Of charge. And a millicoulomb simply means 10 to the negative third coulombs. Now we always go in multiples of 3 here, multiples of 10 to the third. And so the next progression is that we will go a microcoulomb. A microcoulomb means 10 to the negative 6 coulombs. And then the next progression is a nanocoulomb. Which means 10 to the negative 9th coulombs. The way that I like to remember this is nano means negative 9. It's a nice alliteration for you. Nano is negative 9. Hopefully then you can remember that the other one, micro, is negative 6. And milli you should be familiar with already. But these three here, these three are the ones that I expect you to know for tests and quizzes. So again, to recap, these objects that have charges exert forces on each other. They push and pull each other. If they are opposite charges, they attract. If they are like charges, they repel. Our symbol is F for force. We use a subscript of E or electric to designate what type of force. It is measured in newtons, like all forces. And we have our equation, which is known as Coulomb's law, which says that the Coulomb constant K times the charge of each individual object divided by the distance squared is the electric force. And we want to make sure we have things in the proper units of coulombs and meters, as is dictated by our Coulomb's